Okay, so 5 minutes past 4, so I think we can start. I'd like to welcome Enrique Costa, Montenegro. We also know him as Kike. He's going to present which would be the lecture for week 11, which is about security operations and security assessment and testing. So Kike, go ahead, use the time you need, and as always, if one of the I don't know if you want to wait until you finish for questions or...
No. They can interrupt me in the middle of the presentation, no problem. Okay, can you hear me?
Okay, so thank you very much.
Yeah.
Okay. Yeah, and you can see the slides also. Yeah. Okay, so let's start. Okay, thank you very much for attending this course, and I'm gonna start with reviewing the topics for today. So I'm gonna talk about security assessments. In all of my topics, I'm basically beginning with just an introduction of what is understood by a security assessment. Then we will gonna check what we can do in these assessments, what the tests, what elements we can test. And there I'm going to talk about vulnerability scans and penetration testing, how to review code and also test the code that we create, and then a little bit about how to check the logs, the account management, the different accounts that the user has in the system, and a little bit also about the backups. Okay. Finally, I'm just gonna talk a little bit more about penetration testing. That is one course I teach here in one of our degrees in Vigo. And I'm going to explain what are the different types of penetration testing and what are the different phases of penetration testing. Okay. So let's begin with the introduction. So what can we understand by security assessment? And here's a definition that says that security assessment is the process to evaluate, identify, quantify, and prioritize the security issues. The security issues, we understand the policies, the procedures, the technical protections in a system. Please also you should know this, but I want to remind you that we are talking about cybersecurity. Okay, so we are talking about computers, basically, and all the information contained in these computers. So why do we need this assessment? First, the more important reason is to identify what are the potential security issues we have in our organization, in our computers, in our systems. Then, once we have all the issues, we have to prioritize them, okay, to know what is more important and which one can create more damage to our organization. Then, of course, report to management, okay, tell the people that is in charge of the company or the organization that, okay, we have these issues, and usually when you report to management, you always ask for money to solve these issues, so that's the reason you have to prioritize first to know will cost more or will be more dangerous for the organization, and then how much money you're going to need to solve this. And also maybe we need an assessment because we have a compliance mandate. What do I refer by compliance mandate? Right now, when a company wants to hire another company to do something, and we're talking about information that can be sensitive, this company that is going to be hired has to demonstrate that they comply with some security. So this is what sometimes we need these security assessments done in order to comply with these security levels that the company that is going to hire us are asking for. If we don't show this kind of security assessment, we are not going to be able to be hired. So it is also important between companies, relations between companies. So what are the pros and the cons regarding the security assessment? Okay, it's oriented to technical and non-technical issues. Okay, we can see technical issues regarding the problems in computers, but also not technical issues, seem the way that our employees work with the computer. So they have to learn some things that they have to take into account. It has a defined scope. It's just which system and what are the potential problems evaluated there. We know that we're gonna always check the system that we have and what we're gonna check in the system. It usually identifies most of the common technical issues related to our system because we know more or less where to look for, and is repeatable and quantitative. Once we have defined a security assessment, we can repeat, like, I don't know, each week, each month, each year, and see what had happened between this security assessment to know if we have more problems in our systems. But also has some cons, and it is really, really, really difficult. I would say almost impossible to do it well, because right now, every day there are new exploits for different systems. So you have every day to check new things. There are a lot of things to check, web pages, access, a lot of things. So if you want to do it really, really, really well, it's really, really hard to do it, almost impossible, I would say. You can identify a lot of issues. So mainly at the beginning, so there is a lot of things to solve. So you have to decide which one to solve best. And yes, it's also recommended. It only recommends best practices. Sometimes it doesn't give you the exact solution. Just best practices in order to be able that your system work correctly. So this security assessment and testing programs I'm talking about are the main activity, what have to do if we are in a company or in an organization that have some information security teams. It will include tests, assessment, and audits that I will explain the difference between them later. And what we understand for a security test. Security test is just to verify that a specific system is functioning correctly. It could include automatic scans, penetration testing, and manual attempts to undermine the security. Okay, there is a lot, hundreds of tools that can do things automatic in this sense. So we don't have to do it manually. But if we want to identify and solve flaws, some new flaws, we have to do it manually because these tools are not yet created. In the security test, we must design and validate a comprehensive assessment and testing strategy to see that we are doing the thing correctly. And as I said before, must be done on a regular schedule. Okay, mostly the parts of automatic tests, but I will explain later. We have tools that you can program and to do things time to time. You define how much frequently you have to do the things. And the results of this security tests are normally for internal use. When we're talking about security assessments, we're talking more about a security assessment is composed of a lot of tests. Okay. Here we identify the vulnerabilities in the test systems to make recommendations. Okay. We include the use of security testing tools, and we include a thoughtful review of the threat environment, current and future risks. Okay, this is when we create the results, a document with the results. Okay, this report has to be addressed to the management. As I said before, you have to talk with the management of the company or the organization in order to say, okay, we have this, we have identified these problems, and we have to find solutions for them. And then we have the audits. Audits is the higher level of security assessment, where we create evaluations to demonstrate the effectiveness of the controls. Okay, this must be performed by independent authors to eliminate bias. We cannot have our security team to create audits because there can be a bias, and somebody who reads the audits that we have created could say, okay, but this is better done, but another team or people from outside to clearly identify what are the problems in our system. So we have two types: internal audits, that is for internal staff, but external audits is just for outside companies to validate, okay, we have done these audits and we can validate that our system are secure, so you can hire us. Okay. So let's go with the second section, where I'm going to talk about different assessment and tests that we can have in our system, companies, or organizations. The first one are the vulnerability scans. With the vulnerability scans, what we try to do is to check if our system, our application, or if our networks have weaknesses. These weaknesses may be exploited by the internal attacker or an external attacker. An internal attacker can be some employee from our company that is not happy with the company, so he wants to obtain information and maybe then sell to another company, a competitor, or things like that. To do this vulnerability scans, we can use tools that provide quick tests. We can schedule them, and they create reports. But as I said before, these kind of tools are mostly they don't look for the new exploits and things like that. So some things cannot be done with the tools and have to be done manually. Okay. And then inside these vulnerability scans, we can identify three types. Okay, there are the network discovery scan to see what do we have in the network. The network vulnerability scan is, okay, we know what we have in the network. Let's try to break it, to exploit it, and to get access. And then the web application vulnerability scans, where we just go to look into web applications inside our company organization to see if we can break and access the systems. So for network discovery scans, the more typical tool is Nmap. We'll talk about it later. And there are several types of network vulnerability scan. We have the TCP sync scanning. This is, if you know about how the TCP connections are created, you start a connection sending a package with a sync flag. The server that receives it, usually if there is a port open, reply with a package with a sync and AC key acknowledge flags set. And then in order to create a connection, you have to respond again with an ACK. This kind of vulnerability scans, what they do is they send the sync, they receive the sync ACK, but they don't reply to the ACK. They or not reply, or they just send a reset. This way, the connection is not completely open, so most of the firewalls or the IDs, intrusion detection system, that not detect this kind of scanning. But from the origin, they want to create the scan because it has received a sync package and an ACK package, knows that something is there or that a port is open or something like this. Another type of scanning is the connect scanning. In this time is you create the whole connection. The problem is that creating the whole connection, you're making, let's say, noise, and somebody knows, or somebody can know, firewalls, IDS, somebody can know that you're trying to access the system. Then we have another types of scanning that are the TCP ACK scanning, where you don't start with a sync, you just send an ACK, and so the other system detects that something is wrong, there is no sync, so it replies with another package, sending the connection is not to make, but because it has replied, you know something in there. And then we have the Christmas scanning that is more complicated with a lot of flags set in the scanning. Then once we have done the network vulnerability scanning, now what we want to do, the first scans, what we did here is just to know in the network discovery scans what ports are open, of what computers or what systems have different ports open. So when we know what ports are open, what we are trying to do is know what software is running there, what software is listening, and once we know that software, to check if this software has some kind of vulnerability. Okay, there are a lot of information on the internet databases with known vulnerability to different types of softwares, web services, FTP services, SSH services, and day by day there are more vulnerabilities. So once you connect and you check what software you have there and also what version you have, because in the newest version vulnerabilities are corrected, but in the old versions vulnerabilities are still there, you can know if you can access this system, or you can better not access, better exploit this system. All of this type of scanning are unauthenticated scans. We don't use password. We just check the software installed and we see if it has any flaws, and we try to break it. We can also use what is called authenticated scanning. That what they do is, let's suppose, for example, that we have an SSH service running in our machine, and we have a database of known users and passwords for SSH services. So what we do is a brute force attack where we try one by one all the logins and the password to try to connect to the system. This kind of brute force attacks make a lot of noise in the network, so people in the security teams can detect them. And usually services running, for example, SSH, you can configure to only try 3 passwords, and then you cannot try it for an hour or a day or something like that. So sometimes they are not really helpful, this brute force, depending on the service that you want to attack. Then we have what is called the web vulnerability scanning. Is just attacks going directly to web services, okay, web servers. There are a lot of tools for different CMS, I don't know, specific for them, and then are able to check the versions, to check if they have vulnerabilities, to check what is there in order to break the web pages. Once you are able to log into the web pages, maybe you can get information about databases with sensitive information, or maybe you can get a cell into the system, then to upscale your privileges, I don't know, elevate the privileges and get information. So web pages are also a well-known way to get into the system, not only other services running in machines. And also because the web pages are mainly used as a point to connect the organizations or companies with the users. So they are open, they have to be open in the internet, so people can log in there and know about the company or know about the services of the company. So you can try to exploit them. Always scan the web before going to production. This is, well, not only webs, but also software before you launch something. See if it's secure or not. Or if you modify the web, of course, you should scan, things like that. And use scheduled scans to scan all the applications that you have on your web servers. For example, if you know the well-known CMS WordPress, there is, if you look for it, there is a specific tool just to check to see exploits for WordPress. It only works with web pages for WordPress, so it's a good thing to, if you have a WordPress web page in system, to launch this. These are free tools, and not only for black hackers, to people to want to break into the system, but also for white hackers, people that want to check if your system is secure. Okay, so you can, if you have a WordPress web page, just look for this type of tools and check if your system is secure or not. Then we have what is called the penetration testing. Okay, once we have detected what ports do we have in our system open, then once that we have detected that these ports have services that some of them may contain vulnerabilities, what we do is try to exploit the system, try to get into the system and take control of the system. Okay, So this kind of scans, this penetration testing, what they do is just, okay, there is a flaw in the system, I'm gonna try to break it, okay? Sometimes the flaw is not real, or sometimes the exploit doesn't work, but you have to test it, okay? Once the goal here is just test the system, see if it has a vulnerability, see if you can exploit it, and if you can exploit it, then you will have access to the system. Usually, most of the servers that are there are Linux servers, where you try to get when you do a penetration testing is just to get a cell, okay? Just to get a cell when you can interact with the system. Anyway, we'll talk about this more in depth at the end of the presentation. So this is what about vulnerabilities, network scanning, software scanning, web pages scanning, but there is also some other things that we have to check, and this is the software that we have installed in our system. So this can be done with code review and testing, okay? Of course, software is a critical component in a security system. We're talking about in this course about cybersecurity. We are not talking about getting into a company, a person getting in a company and stealing data, well, a real person stealing data. We're talking about computer systems. So usually these software applications of these things that we have installed have access to privileged information. That can be the operating system, can be the hardware, or other resources, like can be databases with all the information about our clients, or the, I don't know, cards, the visas, credit card numbers, things like this, or also information about the medical information, things like that. So we have to maintain our system secure. We have to create a software that is running in our system, must be secure. So the software is the heart of the modern enterprise and must perform critical business operation. And of course, software failures can disrupt a business, okay, with serious consequences. If the software stops working or doesn't work as it should, or we lost the information, there be critical problems to our companies. You have all heard about this kind of malwares, ransomwares that are installed into the system and have made some hospitals, on some electrical companies, on some other kind of companies that have encrypted all their information, and they can no longer work. Well, this is kind of things. If the software is not working correctly, or we lost all the access to our information, we can be in a serious problem in our company. So how can we do this, the code review, that testing? Well, we have to discover security, performance, and reliability flaws in our applications before they go live, they go to production, and they can negatively impact our business. So according to Fagan Inspection, that is a group that released a formal review process, the review of code must be done in this 6 next steps. First, planning, then overview, preparation, inspection, rework, and follow-up. So we have different kinds of code review and testing. The first one is the static testing. In the static testing, what we do is just check the code, the source code, without running it. Okay, just analyze the source code to see if there are flaws there. Okay, there are a lot of automatic tools designed to detect these common software flaws. The typical software flaws are the buffer overflows that may allow us access to the system and things like that. We have, as I said, a lot of tools, and some example of these tools are shown in the slides. Then that was the static. Now we go with the dynamic testing. Dynamic testing is evaluate the code once it's running. Okay, before the code, we just review the source code. Right now, what do we do? Just run the code and see what happens. Here is what we use. It's called synthetic excuse me, transactions. This is, we do a kind of steps in our software, and we know that doing this kind of steps, we have to arrive to an expected result. Okay, so we run this kind of transactions in our software, and we have reached these expected results. Okay, everything is working correctly. But if not, we check that it's some kind of deviations between what is expected and what we get as a result. We can detect then flaws in the system. Okay, if we detect flaws in the system, we must stop this software going to production and then go back and go do some review of the source code to see what is happening and what is wrong. As I said, this synthetic transaction doesn't not follow the user. Okay, synthetic transaction are expected to are done in the way you expect the user to do to work with your software or system. But you know that you can never know how a user use your software. So what we also can do is what is called real user monitoring. Is see how the user is working, interacting with our software. Our software can be a program, our software can be a web app or whatever, and see what happens when it interacts. We can do it for both sides. For one side, it's to see what is the user doing. This is the top-down way, capturing the user experience, and then we can do it the bottom-up way, that is capturing the server-side information. Okay, this is the user doing this, and in the server is happening this, so we can see they are related and they're doing the correct things. Then we have structural testing. This test, what they try to do is examine all the source code and check if there is some part of the code that is called the dead code. These are lines or pieces of code that are never used during the execution of our programs. For this, we use metrics like coverage. What they do is just know how much the percentage of software of the whole source code that is used given relate to the whole code. Okay, and then we have different coverage types that are we check just a statement, just decision. All the decision has been compliant, just condition, multi-condition. You are able to go in all condition, the loops, paths. Okay, there are different types of this structural testing. Then we have another technique that is called fuzzy testing. This technique, what it do is use a specific random malformed data as input to software program to stress the limits and determine if it will crash or break finding previously detected flow. Okay, what do we mean as random malformed data? I don't know. Just suppose that you have a web page where they are asking you for a date. Well, instead of introducing a date, or you can introduce a date with the day of the month, the number 40 or month 15, something that you know that is wrong. Or maybe not numbers and just introduce letters or symbols. Just test a lot of things, strange things in your system to see if there is some things that you have tested that produce an error that shouldn't be. Okay. For this, what we can detect are errors, but we can detect also our software crashes. Maybe we have to introduce a date or a number, and then I introduce a letter, and inside the code, this number is used in certain operation, but because I introduce a letter and you haven't checked if it is a number or not, it produces a software crash. Okay, this is the kind of things that are checked into the system. We have two different types for this fuzzy testing that are the mutation way and the general mutation fuzzing and general fuzzing. Then we have what is called the interface testing. Okay. Usually, if you have work on developing a big software is done in different groups, and different groups make different parts of the software, and all these parts are related to each other using defined interface that are application programming interfaces. So in interface testing, what we do is to check if these interfaces are programmed correctly, or if you can stress these interfaces to give you information what is not needed, and things like that. This is regarding the application programming interfaces, but also there are other type of interfaces that are the user interfaces. And here, when we're talking about user interfaces, we're talking about graphical user interface software that have something you can see, interact with it, or the command line interfaces. Okay, there are some software you have to run it from a cell, and you have to type what you want to run, and also the web interfaces. Okay, there are a lot of interface in the way the user can interact, and also there are physical interfaces. Okay, for example, some application may need to manipulate machinery. You don't use a graphical user interface. You don't use a command line. You don't use a web page. What you use is a joystick. Okay, so this is also an interface to using a software. So you must test it to see if everything is working correctly. When I say a software, I say a button, different buttons. The buttons are working correctly. What happens if instead of pressing just a button, I keep it pressed for 5 seconds? If everything working correctly, things like this. And then we have the misuse case testing or abuse case testing. That is to evaluate the vulnerabilities of your software to known risk. Okay. So first, what the testers do is just they enumerate the known misuse cases, and then it ensures that the application can handle these inputs that are not done correctly. Okay. So this is another example, like the example I said before about fuzzy testing, is just inputting something that is doesn't have to be. Okay, you must input a number and you put a letter, things like that. And in this case, if you have done your software correctly, you are expect that some exception be created and that you can handle this exception and do things properly according to these exceptions. What are these kind of misuse case testing? Here you have some. You are required to introduce some form fields, so you, on purpose, leave them empty. Data mismatch, where you enter incorrect data types. Field limits, where you expected to put a number between 0 and 100 and you put 1,000, things like this. Data bounds, where you exceed range. Reasonable data, where you introduce invalid data. Unauthenticated web pages is when you try to open a web page without logging in. Just suppose that you have your web page and you have to log in to go to a different web page where you have information. What happens if I don't go through the login web page and I open directly the other page? Can I access this information? These are kind of things that you can use when you're using misuse case testing. Regarding test coverage analysis, as I said before, it's completely impossible to completely test any piece of software because there are too many ways that a software can malfunction incorrectly or can have an attack. So this test coverage, when we try to create a report and say how much have we tested, what we have is usually this number that is the test coverage, that is number of use cases that I have tested divided by the total number of use cases. What is the problem here? That is really to know how many use cases I have tested is easy because it's the test that I have done. Okay, this is really easy. But what are the total number of use cases? We never know. Okay, so it's really difficult to get this test coverage when you're really doing an analysis. Then also with all software, you have to do maintenance. Okay, you have to review from time to time that everything is working correctly. This must be done in with the next step. First, a software validation of the plan revision. Then, once we have evaluated and we have detected anomaly, evaluate this anomaly, identify why this anomaly is there, and try to solve the problem. Propose change in the assessment. Propose test change in the way we test our software to include these errors that we have found. Task iteration is just go again to the beginning and try to test it again, and then update the documentation of our software to include these problems that we have detected. Okay, with this we finish the part of code testing, and we go with the log reviews. As you know, logs are usually plain text files with information of all the steps that software has gone through, all the things that it has done. So there are if the software functions correctly, most of the information is useless because it's good, but it's a nice way to detect flaws in our system. So there should be check periodically to see if there is something wrong with our system. Also, in the case of attacks or intrusion to our system, they can give you information about how the attackers have access to this and have created this security incident. So how should we review the logs? We have let's say four phases. The first phase is, of course, configuring the log resources. We have our different software in our system. We have to see where there are all saving the logs to know where we have to look for information. Then perform log analysis is just usually with automatic tools, just checking the log if something has done wrong. In case we detect that something has gone wrong, just identifying what has happened. And also what is a good thing to do is to maintain a long-term storage logs before you can have security incidents that you don't know that you have it, but half a year later you detect that is something in your system that shouldn't be there, and you can discover that it have entered 6 months ago. If you have delete all the logs, you will not able to find a way to know how this security incident has happened. But if you keep the logs for the long term, so you can check and try to detect what has caused this security incident. Also, what has to be done, and from time to time, is to review the account management. Okay, different employees in our companies, in our organization, have different access to different things. Okay, so we should review if a user has access to something it shouldn't have access, or if a user do not have access to something he or she should have access. Okay, so this is what we are talking about, account management. And especially we have to take into account what is called what are the highly privileged accounts. Okay, these are the more prone to be attacked, because with this you can obtain a higher number of information with low security accounts that only have access to files with no sensitive information. So to do this, what we should do is compare the list of users with privileged access and the privileged access rights, both lists, to see if they match, okay, if with the list to access to the system in order to know if there are access to any element without privilege need, okay? So compromising privileged users of the system is the preferred technique for attackers. Of course it is. We will see when we're talking about pen testing. The step once to have get access to the system, the next thing that you have to do is to elevate your privileges and to obtain an account with access to everything, like a root account in the Linux system or an administrator account in the Windows system. Because once you have this kind of accounts and once you have escalated your privileges with these accounts, you have information to everything. Okay, everything in the system, all the information you can have. So how are the ways to accomplish access to these accounts? First thing is to compromise an existing privilege account. This is just getting the login and password of an account that has high privilege. Another thing is if you just compromise the system, one thing that hackers usually do is they don't keep this account for them, because maybe this user can see there is something strange been doing with this account. So what they do is they create a new privilege account, with different names. So you can log in later, the hacker can log in later with this account and access to privileged information. And then another thing that can be done is just elevate the privilege of a regular user account. Okay, just if you have access to change the information or change the things that you can access, you just elevate your privilege. Just suppose that an employee that is not happy in the company just is able to get access to a high privilege account, and with this he can change his privilege of his normal account. If he changes the privilege to a higher account, he will be able to get to a lot of information about the organization. And finally, backup reviews. Okay, check the backup to see that everything is working correctly. Okay, so for this you have to create backups in different devices, different hard disks or different media to store the information. Also in different computers to see if one's computer get hacked or there is a ransomware there. If you don't have a backup in any other computer, you won't be able to recover the information. And if you are working in a company, also in different locations of the company, to see if one location of a company can get compromised, you can have a replica in another location or even in the cloud or things like that. For this, you have to check if the backups are done correctly or they are not correctly and things like that. So we come to the last part of the presentation where I'm going to talk about penetration testing. I don't know if you have any questions so far. If you have a question, just let me know. If not, when I finish, of course, I'm open to questions. So what is a penetration testing? The definition of a penetration testing is a security procedure to determine if a system can withstand an intrusion attempt for a hacker. Okay. How is this done? We have several steps. If you check the literature, some people say there are 4 steps, some others say 5, others say there are 6. Well, more or less are the same steps. Some of them are joined together. First is the basic requirements of the systems or of the system or of a company. This is to check If we're going to go for a company just to check all the information related to this company in internet, all the phone numbers of all the email addresses of the employees, all the computers they use, things like that. Then once we have this, once we have the information about different computers, different IP address, what we do is just check the different computers to locate if there are open ports, to see what services we have running in these computers. Once we have this, we go with the network vulnerability scan. That is to find flaws in the system, unpatched vulnerabilities, all versions of software, things like this. Also, we can check this being a company, what I explained before, attacking what is the web pages of the company to see if we can gain access to the system, or we can discover databases with sensitive information. Then when we have discovered the vulnerabilities, what we should do is just use exploits to get into the system. And then when we are into the system, we can elevate privileges. And finally, manual proving and attack attempts. There are different types of penetration testing. One is the white box. Well, there are different ways to differentiate penetration testing. One is the white, gray, and black box penetration testing. The white box, what they do is, if you want to check your security of your system, you hire a group of white hackers. Okay, they do ethical hacking. They try to break your system, but not to obtain information, just to tell you what are the flaws of your system. And in order to reduce the time that these people will be trying to break your system, what you do is information about all your systems. You give information about all the computer, IP addresses, locations, things like that. So this way, these white hackers can bypass the recognized steps, so they reduce the amount of time they spend in the system. Another type of penetration testing is the black box. In here, you don't give the attackers any information, and it just simulates what an external attacker, some people a hacker or a black hacker will try to do to get access to your system. And then we have what is called a gray box penetration testing. That is something in the middle. You don't give a lot of all the information, but you give some information, so they know something in order to speed the attack. Will get the results of a black box, but costs or time less than a white box. Okay, because you give some previous information. There are also some what is called blind test. Is usually if you are in a company and you care about your security and you have people hired in order to check the security of your systems, of your web pages and things like that, there are two teams. Okay, one thing is the red team, that is the one in charge of attacking. They are your employees, but their mission is to attack your system in order to detect flaws. And then you have another team, that is the blue team, that is, okay, I know I'm going to be attacked and I'm the one in charge to defend the company. Okay, this is like a castle. There's the people from outside that want to get into the castle, and the people from inside that try to stop the people from outside to get into the castle. Okay, so the blind test is the tester only has publicly available data to work with, and the network security test has prior knowledge of the test to defend. Okay, the people who is defending will know that they're going to be a test. The double blind test is that you don't give information to any of the teams. The one that are going to defend don't know they're going to defend, and the one on when they're going to be attacked. And the other one attacking doesn't know that there are other one defending. Okay, and the targeted test is when both parts of the system know that there's going to be attack and there's going to be defense, and you attack just one thing about related with the system. So let's see the phases in more detail. The discover or recognize is just to get printed and gathered information about the target. As I said before, you can find information in Google, in web pages, and checking email, trying to get all the mails from a company, see located what are all the web pages related to a company, get what are the installed, these web servers, what IP they use, what software they used for the web service and things like that. Then we go with the enumeration. Enumeration is ping sweeps is to know of these machines that I have found belonging to a company, to know which one the machine are on, they're responding to ping. Then port scan is to see all the software installed in the servers, in the web servers of the company or the server providing application for the company. Then banner grabs. Banner grab is whenever you log into a service, usually the first thing they do is they respond with a banner. In this banner, you usually get information about what software you are using, the name of the software, the version of the software, the year it was created, and things like that. If you trust these banner grabs, you cannot always trust because maybe there are honeypots, but if you trust them, they will give you information about flaws. You can then look for repositories of information of vulnerabilities, check this specific software, check this specific version, and see if there are vulnerability there. If there is a vulnerability there, what you do is a vulnerability scan is, okay, I think there is something there that I can get access to. So gonna check if there's a vulnerability there, and if it says yes, what I do is the next phase. The exploitation phase is, okay, there's a vulnerability, and what I try to do is use software. I'm gonna tell an example of the software that you can use, and then try to break this vulnerability, try to exploit it in order to gain access to the system. Okay, this is the exploitation. Once you have access to the system, you have exploited the system. Okay, and then it comes the post-exploitation phase. There are different things that you can do here. The first thing that you usually do here is when you exploit the system is you usually get a cell. These Windows servers, you get a command line where you can interact with the system. In Linux servers, you get a cell, and what you try to do there is to know which user you are in the cell. Okay, do a who am I in the Linux cell to see what user I am. If I'm a root, everything is done because I have access to everything. If I'm not root, the next thing that you do is to check what can I access, what files can I access, and get information from these files and things like that. Next thing that you do is try to escalate your privileges. Depending, you check if you are in a Linux server, what version of the kernel you're in, and different kernel versions have different exploits to upscale privileges. Okay, so you try these exploits, and if you succeed, normally you get a root account. Other thing that you do in the post-exploitation is first clean all the marks you have left in the system, saying that you have logging into the system. Okay, remove logs of entering, remove different things. So whenever the team that is defending the system try to look for information, how do you get in? You have already removed all the paths that you have followed in order to get into the system. Then other things that hackers do when they access to the system is they usually open a backdoor. Okay, you open a backdoor, so you have exploited the system, you can leave the system, but in order not to repeat all the steps, and because maybe they have updated the software that has an exploit, and so you can no longer get into the system, what they do is they create a backdoor so they can access or create a new user with root privileges. You can access from remote, things like that. These are all the kind of things that are done in post-exploitation in order once you have access to a system. And then, of course, if you're doing this penetration testing and you are in the ethical hacking, you are just doing this to find the flaws of the system and report to the management, you do two kind of reports. One executive level reports, when you do the findings of our without technical detail, you say, okay, here I am, I have access this database with all this information, with this credit card information, all your user, all the emails account and things like that, but without technical data. And then you create a technical report that is going to the people in charge of the security in the system in order to tell, okay, I have followed exactly these steps, I have used this software, so they know how you have entered and they can close this way to breach into your system. Okay, I'm talking here about the way to access system, how to break it, how to use exploits, and how to discover vulnerabilities and things like that. But the less strong step in all the chain about security in computer system is the human. The less strong step are we. We are the one that can be more influenced more easily in order to get access to the system. Okay. So for this, we have what is called social engineering. You should know all about this. You have to, I'm sure that you have received phishing mails or you receive phishing mails every day. So what we understand for social engineering, the process to manipulate individuals so that they perform actions that violate a security policy. Okay. Usually it's done offering tricking the user to click a link. Once they click a link, they download a program or they execute something that breaks the security in the system, and then the hackers have access to the system. Okay. The way to do this social engineering is, of course, phishing is the most popular way of social engineering, and its attack is conducted through digital communication. Well, mails saying, okay, your bank account has been hacked or has lost information, so please log in here and give me again your details of your bank account, your details of the bank, login and password. Okay, this is phishing. Okay, then we have spear phishing. This is more complicated to detect because it's a phishing attack just going directly to one person or one individual or one specific group. So hackers here have to obtain a lot of information about what these people like, what the people don't like, things like that. I don't know. Suppose they like wine. Well, they offer a product of wine and they say, okay, here you have in a contest and you can win this bottle of wine. And people, because they like wine, they usually click. Okay, but this is more direct to one individual, not just in general phishing. Then we have whaling. This is what is called the hack the CEO. That is attacks specifically go to senior executives or individuals. Okay, this is the typical attack where you try to hack the CEO, and once you hack him, you send mails passing as you are the big boss of the company to the people in charge of transferring money and say, okay, you have to transfer this amount of money to this account. I cannot call you right now. I am in an important meeting. Transfer as soon as possible. So the hacker has hacked the boss of the company. In this pass as he was the boss of the company, gives a bank account in whatever country. They send the money and then the money disappears. Then drive-by download is just individually redirect the user to malicious distribution server when they can install malicious software. And then we have pretexting, that is social engineering using text messages. Regarding the different penetration testing phases, the most known tool to do this is Mmap. I don't know if you know it. This is well, there are graphical interfaces for the tools, but usually it's a command line tool like the one you see here in the screen, where you just give some option, and then you give in this case scanme mmap.org is a computer that the people who created Mmap has opened, so you can scan them and see what is there. Okay, this is give you information about different ports that are open. For example, here this machine has in port 22 has an SSH, the open SSH version 3.9. Okay, you get information. And SMTP, you have a 53 open, you have 80, you have a web server, Apache web server. So you get a lot of information. This is just to scan ports. Well, not just, mainly to scan ports and see that there are ports open where you can look for information there, or to see ways to hack into the system. This is the discovery part. Just check the machines to what software they have installed and what ports they have open. Once you have this, what you have to do is enumerate the possible vulnerabilities that are in your system. For this, there are the main two tools are Nexus vulnerability scanner and OpenBus vulnerability scanner. Okay, what they do is, given this port, they check if these ports have vulnerabilities. Okay, if there is possible to create an exploit. These tools are really useful, so you can have it installed in one computer in your network, and you can program them to do schedule vulnerability scanners of the network and check if everything is working correctly, or you have problems in your system, things like that. The big difference between them is for Nexus you have to pay. I think you have to pay a lot. It's of course better, and OpenBus is just an open source vulnerability assessment scanner. It works good, but it's free, so maybe it's not so good as the other, but you have to pay. But it's good enough if you want to check the basics or discover the basic vulnerabilities in your network. Then once we have the vulnerabilities, then we go with the exploitation phase. Exploitation phase is, okay, there's a vulnerability here. I want to exploit it and see if I have access. And the most known tool for this is Metasploit. Metasploit, has a user interface also, but also a client line. Well, you just load out and exploit. Once you know that a machine is an exploit, you just load it. You define what is the IP that has an exploit, what port it has an exploit, and then you just run exploit, and then the exploit happens, and then you get the information into the system, and you hack into the system, and like in this screen in the sample, you hack into a Windows 7 computer, and you get information of the system, and then you can see what kind of information there. You are logging. You are a Metasploiter. Metasploiter is a kind of cell provided by Metasploit that allows you to do a lot of things in a hack system: download file, upload files, clean all the paths that you have done, elevate the privileges of the things that you have done, things like that. And then, as I said, plus exploitation, once we are into the system, try to get as much information as possible. And for this, you use the knowledge of your operating system. Finally, once you have done a penetration testing, and of course, if you are a white hacker, ethical hacking, and you're doing this because a company pays you for, what you do is a report, okay? A report of the things that you have done. The key elements in this report are the threats, the vulnerabilities, the probability of exploitation, the impact, and the recommended actions. Okay, and thank you very much for listening to my presentation. And right now I'm open to all the questions that you have. Thank you.
Any questions to Kike? Okay, there are no questions.
Okay.
Okay.
Hope you have enjoyed. If you have, if you review the slides and you have questions, you have my email address there. You can write me an email and I will help you.
Okay, thank you very much, Kike, for your presentation. It was very interesting. The following session will be on Monday at 10 o'clock Jordan time. And thank you very much to all participants. See you on Monday.
Okay, bye-bye.
Bye.